So welcome everyone to this talk on diagnosing failure modes in your ML organization. So it's my pleasure today to introduce to you Dr. Jason Sleight and Daniel Yao. They are both working at Yelp. Jason is a group tech lead at Yelp. He focuses on the intersection of machine learning and also system engineering. And he leads initiatives to create platforms for ad hoc computing, ETL, and also machine learning. On the other hand, Daniel Yao is the engineering director of the applied machine learning team. He leads efforts on product-facing ML initiatives such as recommender systems, revenue optimization models, and also content integrating signals as well. So without further ado, Jason and Daniel, I will let you take the floor away.
Thanks so much. So these are us. I'm not going to go into details since Jeannie already did that for us. First, I'm going to give a little bit of overview on what is Yelp. So Yelp is a mission connecting people with great local businesses. Our scale, we have roughly 31 million app unique devices a month, 224 cumulative reviews as of last December, and we kind of are a review site people go to find businesses. We have tons and tons of ML models. So this is like our home screen. On the screen, all by itself, there's 10 or so ML models that are powering various which text we show, which icons we show, which businesses we recommend, which photos we show, which titles, all that kind of stuff. We also have models in ads and search ranking, like you might expect, and make estimations on the wait time you'll get at a restaurant, which is now starting to become important as restaurants reopen from COVID, to identifying what the most popular dishes are at a restaurant or in your neighborhood, and all kinds of things in between. Yelp's ML org has hundreds of ML models running in production with a very wide range of sophistication. So at the simplest part, we have just manual heuristics where people built a decision tree and it runs these things all the way up to deep learning neural networks. Operationally, we have a bunch of kind of just offline ad hoc models people build to kind of gain insights, up to search ranking and ad targeting that run in real time with very high QPS and have to score thousands of candidates per second. From the business objectives, we kind of try to frame our ML models in being a few different main categories. There's some kind of content models like photo recommendations, text understanding, that kind of stuff. There's a bunch of consumer models, which is kind of trying to recommend the right businesses to the right users at the right times. And then there's a bunch of strategic models like ad pricing, recommending to our sales reps which businesses they should contact, setting advertiser budgets, all of that kind of stuff. Yelp started hiring like dedicated ML developers around 2015 and have scaled that up to somewhere around 75 kind of regular ML practitioners today. We've experimented with a few different organizational structures over the years, which has kind of given us some pros and cons of different ways you can organize your ML org, and we're going to talk about that a lot more later. So kind of the main question of today's talk is your ML org effective? And it turns out it's really hard to know whether you're being effective. So I'm going to cheat and answer an easier question on is your ML org ineffective? Because it's a lot easier to tell when things are broken than if you're doing a good job. So we're going to focus on what are the main ways that you should look out for that your ML org could be broken, and how can you try to fix those things. So pitfall number one is that your ML projects really take a long time. I tried to think for a little bit about how long it should take someone to do various tasks, and I came up with kind of a nice 1 month, 1 week, 1 day, 1 hour, 1 minute kind of scale where I should be able to know my model's current performance in a minute. I should be able to know, like deploy a new model to production in an hour. I should be able to retrain a new model on the same features with fresh data in a day and get it completely deployed out to production and know its performance and everything. I should be able to add a new feature in and do all of the lower steps in a week. And I should be able to do an entire ML project for a brand new domain in a month. I think these are realistic estimates that we often don't hit for various reasons. I might kind of go into a little bit more depth on each of these as we go. So doing an entire ML project in 1 month, I think the biggest reason that this doesn't happen is data scientists and engineers who are building these models always try to create the perfect model. And the cases that I'm involved with, after a few weeks, we usually have something that quote unquote works. It's not perfect, but it's better than our baseline. It's better than random. You could get some value if you deployed it right away. And we've really been pushing our ML projects to kind of iterate in this really rapid workflow where deploy that model that improves your performance by a little bit, and you haven't investigated all the features or tuned every little hyperparameter or explored every type of model you could do, but start getting some value right away. And you can always iterate if there's still room to improve. So while you're running your A/B experiment to see if your model is better, you can be still investigating new things, and you can kind of have this pipeline of models that is continually moving out. That's kind of how you get to this 1 month. So how do you add a new feature in a week? I think this is mostly determined by data availability and quality and discoverability. If you want to add new features and you have to re-engineer everything from scratch, where you have to process the raw data logs and you have to take out all the bots from your logs and filter out all the nulls and like clean all that data up, it's really hard to do it inside of 1 week. So the ideal world in this is you kind of have shared platforms for your ML features that you share across your model. And that means that the work that someone does to clean all of that data and make it a good feature that's available and historically backfilled and available for all your data, you get to amortize that across all of your models and kind of get this 1 week on average, right? Where sometimes it'll take a month, but then the next one only takes a day. You kind of get the averages out. The other big thing I think is important to call out here is to separate your feature engineering code from your model training code. And then kind of make your model training code be parameterized and agnostic so that it takes in some input data matrix of whatever features are there, and it can train a model from it and give you all of your metrics, and you can deploy it without having to do lots of thought on it. If you have kind of one model that goes all the way and does the whole thing, then it gets brittle and it crashes and it's hard to debug, that kind of stuff. So next is, how do you retrain a model on fresh data in 1 day? I really love this PhD comics about it, which represents my grad school code as well. And I think in the ML world, a lot of people often will build a Jupyter notebook, and they'll use that as like, that's my model training script. It's this Jupyter notebook, right? The problem with that is it goes out of date, and the upstream dependencies changed, and there's no instructions on how to use it. And I don't know, are the slides moving? Do you see the slides moving, Daniel?
I do see your slides moving.
Okay.
Maybe, Mina, you want to drop the call?
Just you, Mina. I'm going to plow ahead. So, you really want your notebooks to be with instructions on how to use them, have comments, have it be rerunnable. Ideally, you can just hit like run and it will all work, rather than it being super painful and someone tries to run that notebook and it doesn't work because the cells were run in the wrong order and the dependencies changed and everything like that. You want your model training code to be checked into version control and parameterized to say, please train on the data from this date range, and just hit run. And it will automatically spit out the model that you need and all the metrics and everything like that without requiring anyone to really intervene and babysit that model. So next up is deploy a new model version in 1 hour. So your model platform needs to hide all of that complexity between training and serving the model. And there can be a lot of complexity. So in our case, most people train their models using Python or Spark or something like that. And if you want to then take that search ranking model that you trained in Spark on your millions or hundreds of millions or billions of data points and then deploy that online, you're probably not running Spark in your real-time execution engine. There's some translation layer that happens in between. And that needs to be completely abstracted away in your model platform so that people don't even know that it happens. So to do this, I really think that you need every model to have its own unique ID. At Yelp, we're using MLflow, which is a really great system, open source, put out by Databricks in combination with MLeap and Spark in order to do this. And every model has its own unique MLflow run ID. And when you want to deploy a model, you just swap out and say, please use this other run ID. And then your model platform will take that and run with it and make it all be available for you. So last, know your model's performance in 1 minute. So this is an example of what the MLflow GUI gives you when you're logging all of your model parameters and metrics and have all these different run IDs. It gives you this nice little UI that said, and this is just like the open source MLflow system that we're using. And it gives you all these things and lets you compare and know exactly what your model performance is. Just right off the bat, go to a UI, you can know exactly what it is and compare it with all of your different ones, rather than having to search through your notebooks and figure out what was the performance on that one again, and what was the parameters, I don't remember anymore, and what was the date range. And it's so hard to lose track of all of that stuff as you go. All right, so that's pitfall 1. If you do all of those things really well, then you'll be able to do an ML project within a month, and that's like you'll have your ML experts and they can run their projects and they'll do really well. The next challenge then though is how do you scale this out to impact other business areas, right? You probably don't have ML experts for every single thing that you're trying to do. And how do you leverage that precious, expertise to impact as much of your business as you possibly can? And really this is to say that like you will always have more problems than you do experts. This is kind of fundamentally a skills mismatch in ML because you can apply ML to a huge number of possible problems, but ML expertise is really, really hard to acquire. Becoming an expert in ML is essentially a master's degree, and ML experts are really expensive to hire. So you either have to spend a lot of money to hire these people with lots of training, or you try your best to have your current engineers learn this ML expertise, which takes a long time, and it's unclear whether they'll have the right math background to really understand it, all that stuff. You will always have more problems than experts. As a consequence, you kind of have this spectrum on how you scale this out. And you kind of have, the two extremes are either your projects use really simple techniques. So you don't use the most sophisticated ML, you just use heuristics or a manually constructed decision tree or a simple logistic regression or something like that, where you don't need as much expertise in order to train the models and tune them and make sure they're not overfit and biased and all that kind of stuff. Or you can have your experts lead multiple projects on different teams and say, you're not going to be the one doing every tiny little detail. You're going to be a super project leader and work on 5 projects at the same time to build ML models all across the organization. And now I'm going to kind of walk you through a case study that we've done at Yelp for a single problem where we've kind of done different points in the spectrum to see what the trade-offs for this was. So to give you a little bit of context, back in 2017, Yelp decided we were going to build an ML model to suggest which businesses our Yelp users could review. We had an existing heuristic system that was based on simple features like if you uploaded a photo, then maybe you would be willing to write a review, or if you had called the business or made a reservation there or done a check-in or something like that, right? And this accounted for around 10% of our total Yelp reviews were written through this kind of your next review awaits kind of flow that's down there. The team that owned this feature was a product feature team. They had, Android developers and web developers and some backend developers, but they didn't have any ML experts at the time. So our applied machine learning group came in and tried to help them. So our first take was the kind of team that owned this feature built an ML model with a little bit of expert consulting. So we didn't really have the ML expert go in and train the model themselves or do lots of code reviews or go to lots of meetings or lead a project or anything like that. Just kind of like a little bit of consulting and saying, do it this way, use sklearn to train your thing, stuff like that. We learned just a very simple linear model that replaced a previous heuristic weighted sum. And the end result was we did not ship this model. It ended up having really poor performance on counterfactuals, and it didn't work out. The key takeaway from this was that we didn't have enough expert involvement. And then when we went to deploy our model in live traffic and its performance was 5% or whatever it was worse, there was a lot of confusion. And no one really was equipped to understand what went wrong or what they should have looked at or whether the project should have been refactored in a very principled way. There was just not enough expertise floating around. And the ML expert that was consulting on the project also was kind of not that ingrained in the system. So they didn't have that institutional trust with the team to help them figure things out. And it was a bad situation. So we came back and said, well, that's sad. We still think ML is good to use in this use case. So we're going to try again. And we went back again, and this time we went completely to the full other end of the spectrum, and we had our ML experts from our applied machine learning group come in and just build a model for them. And in progress, they re-engineered some of the feature representations to make them more applicable for the kind of model we were learning. It's still just a linear logistic regression model. And our kind of ML expert owned this entire process from start to finish and went all the way from here's the features I'm going to do, here's the model I trained, I deploy it, I run the A/B experiments, everything. And just kind of I just go into your code base and do your work. The result, the model shipped and improved the business KPIs by 5%. So great, everyone's happy. And the key takeaways here are that, by having an expert be directly involved in the system, they recognized the need that we needed new features and re-engineering them, and they could encode it in a way that would use ML more effectively. But the downside is that since the team that owns this product feature wasn't really involved. They were not equipped to own this model long term. And if something weird happened, they had to come contact this ML expert to be like, hey, what's going on here? Or can we add a new feature or something like that? They needed help. So come back again, third try. We found some promise on this. We'll come back and do it again. We then took an ML expert from our applied machine learning group, and we had them lead a sequence of projects with this host team where they're kind of the project leader, and they were leading some other projects at the same time. And this team of 2 or 3 engineers from the host team worked with this expert to engineer more features, move to a more sophisticated linear model, then move up to an XGBoost model instead. And as a result of kind of shipping this thing all incrementally, we ended up getting another 10% improvement. So it kept the impact high. Everyone felt good about it. But because this ML expert participated for a sustained period, the kind of project team was able to understand the best practices and take on ownership a lot more, so they could propose things like, hey, I bet if we add a new feature related to whatever, that would be a good idea. And our ML experts would be like, yeah, that does sound like a good idea. Why don't you get the feature ETL'd and retrain the model with it? And the engineers were able to do that because they were involved with the whole process. So this brings us to where they are today. This team is now really comfortable owning ML initiatives without external assistance. They've since hired a couple of more data mining oriented people to work on this and other problems that are in their team space. And they continue to iterate on this model themselves, as well as apply ML to a bunch of other problems in their team space. So it's been a very successful kind of partnership transition growth for this team's ML trajectory. So now I'm going to hand it off to Daniel. He's going to talk a little bit more on how you build up this staff of experts.
All right, thanks, Jason. Daniel, the engineering director for the applied ML team at Yelp. And I'll talk through the third pitfall in our presentation. As Jason mentioned, difficulty in building up a staff of. This section is going to be a little bit more about Yelp's journey through the problem area, so it may or may not generalize to your organization, but we thought there were some interesting lessons to share nevertheless. Next slide, please. So several years ago, we found ourselves in this situation. We were having trouble building up a good staff of ML professionals. Now, at the time, Yelp was organized as a collection of decentralized product teams, as depicted on the left here. So these product teams might be ad delivery, consumer notifications, search, and so on. And within these teams, there might have been ML engineering or related positions. I've colored those positions as red dots in this diagram. With other over time, we started pulling those engineers into a central team, which is now applied ML at Yelp, structured to support all product areas. And I'll talk about how this change has solved many of the issues that caused the aforementioned pitfall. There's a variety of ways on how to structure a central team, depending on a company's specific situation, so I won't go into too much detail on that. Next slide, please. So one thing that might be obvious is that in a decentralized structure, there is lack of mentorship and community for ML engineers. I will note that we definitely tried to promote community through various forums and venues, but we still experience. And in particular, the ratio of full stack or other type of engineers to ML engineers is typically very high, which meant that outside of a few core areas, there were often scenarios where an MLE would be the only such engineer on a team. In contrast, with the more centralized format, senior engineers are much more accessible, and it's significantly easier to build out a common pool of knowledge, processes, and best practices. Next slide, please. In the decentralized format, one issue that became apparent was at the time we had a very generalist role that we hired into via a central hiring pipeline. This was titled data mining engineers. And this role meant different things to different teams. Some teams really needed data back scientists and so on. So frequently, engineers might be assigned to teams that had different needs versus their core competencies and interests. Organizationally, no one was strongly incentivized to improve the hiring process for the company as a whole. Now, conversely, with a more centralized format, we've now put in a lot more effort defining roles, improving team matching, and improving hiring practices, especially given a lot more at stake if these are not polished. Next slide, please. On the leadership front, in the decentralized world, we had a lot of strong product leaders, but they were not necessarily a value that ML techniques could provide, which leads to downstream implications in terms of product design, project staffing, and meanwhile, with a well-established central team, there's naturally a partner to those product leaders to provide input on business, product, and team planning. Next slide, please. So all the issues above meant that in the decentralized world, we experienced low engineer retention and teams were frequently backfilling, sort of ultimately leading us to this pitfall of difficulty in building up an effective staff of ML professionals. Today, with the central format, we have a larger and sort of higher tenured team, and we feel that organizational structure is a strong factor in these types of problems. Next slide, please. So yeah, so that's all the content we have for today. Thanks for listening in, everyone. Both here representing Yelp's AML team. Just to throw a pitch out there, we are currently hiring for multiple positions. So if anyone is interested, please let us know. If you are interested, on the next slide, we have a brief overview of the different roles that exist at Yelp, and feel free to take a look.
Cool, thank you, Jason and Daniel. So we do have a few questions from the audience. The first question is, what can you use to version control notebooks?
Yeah, so when I was talking about that, I guess there's two approaches you can take here. Approach one is to say, don't train your models in notebooks. Use notebooks for prototyping things, and then take that code and write a batch that will train things and check it into Git and write tests and do stuff like that. That's what we usually promote. At Yelp, we have a system that we've built to do like notebook archival kinds of things. So there's various approaches you can try to take to do it, but as it relates to making your model training code be reproducible, don't make it be a notebook. Notebooks are for prototyping, not for production model training systems.
Cool, and when you say that each model has its own ID, does this mean that each model version has its own ID, or does it mean that all have, like, how does versioning work in this case?
Yeah, so it's actually both of those. The way that ML flow structure stuff, so this is what Yelp used, but you could pick your own kind of stuff, is you get these different experiment IDs, and we might have one of those be ad targeting, right? And that will be a single ID, and it'll organize everything into that thing that kind of groups it in a nice way. But then every version of the model that you've trained will have its own ID. So if you've trained the ad targeting model with the June 1st until now data with XGBoost and these 10 features, that will be one run ID. If you train it again at that same stuff, but an 11th feature, that'll be a different run ID. Basically, every model binary is its own run ID.
Cool. And so how did you arrive at this set of tools? Like you mentioned Spark and MLlib. Did you have to do any research beforehand, or was it pretty much, let's try this tool and then let's see how it works?
Yeah, we did a bunch of investigation on this probably in like 2019 to kind of pick one system that we wanted. The biggest constraint that we really cared about was portability of our models. So we run a bunch of models and like deploy them in a lot of different ways. Some of them are in Spark, some of them are in microservices, some of them are in Flink, some of them are like directly in our Elasticsearch ranking clusters. And this combination of Spark for training, MLflow for kind of logging and archiving, and MLeap as our kind of interchange format to our real-time engines worked out really well for us and was kind of the best solution at the time. We've been pretty happy with it. It works pretty well.
Cool, great. So we're going to transition over to more about the organizational structure. One of the question is, are there any differences in how each role does data engineering in your ML organization?
I will say that, Jason, you might have your own take, but I would say that data engineering is definitely a shared task. Applied scientists or data scientists need to do some data engineering. Data backend engineers do, of course, do a lot of data engineering. And ML engineers also do a lot of data engineering. So it really depends on the project, depends on the product area. It's definitely shared.
That makes sense. Yeah. Okay. Then can you also talk about the handoff between a data engineer versus a data scientist?
So the way we've been structuring these on our projects is we'll staff a project with like multiple different roles of people. And it won't be necessarily like a strict handoff as, oh, the data science part is done, now to data engineering. It'll be more collaborative and like interspersed as it goes.
Then can you say a little bit more about your hybrid team structure? Like how do you manage tasks and resources in a hybrid setting?
Yeah, so this is, I did mention many advantages of the central structure. This is a probably greater challenge in the central structure. Getting enough visibility into product strategy across that task falls more to, for example, myself or my group product manager counterpart. We have a little bit more responsibility in keeping up to date on those things and sort of filtering that into strategy for the team. At the same time, we do have product teams that focus on specific product areas, and so they have maybe better visibility into specific product areas. We also have teams that are designed to be a little bit more platform oriented, perhaps connected to a particular data entity, and that has a different type of management structure. So I guess what I'm trying to say is there's not necessarily a single solution, but a set of solutions to try to.
Cool, great. Thanks for the response. It seems like it actually answers multiple questions over here. A lot of questions are relating to how you assign the engineers to a particular product or a particular project here. So in terms of just working day to day, is it right that your team is currently using an agile framework? Like how?
It varies, I think.
I would say it depends on the team. Some teams adhere more or less to that. We don't have a super strict culture about that.
Okay. Then someone has a really specific question about how you conduct your check-ins. So do your data scientists usually have like bi-weekly check-ins or like even bi-weekly targets or weekly targets that they should meet, especially when you are advocating for this like lower ML project velocity timeline?
Again, it depends on the team. I would say the most standardization we have is more like quarterly targets, and sort of dependent on the team how they want to break that down into milestones or weekly or bi-weekly targets.
Okay, cool. Keep the questions coming if you have any. We have 1 more minute for maybe 1 or 2 more questions. Maybe a question that I have is, do you find that it's easier to have a consistent culture when you have a centralized like hybrid team, like versus what is the term that you used just now, like a decentralized product team?
For sure. Much easier to have a consistent culture. For example, it's easier to schedule, biweekly all team meetings, and highlight projects and best practices. How should we do documentation, that sort of thing. Much easier to pass that information around.
And what advice would you give to a small company if they are thinking about hiring machine learning talents versus ML ops specific talents? What would you think is the ideal ratio between the two?
I would say if you're very small, then buy a cloud managed ML ops solution from AWS, GCP, Databricks, Azure, so somebody like that. Everyone offers an ML ops solution. Just buy one and then have like one person manage the integration and then have bunches of data science people to use it.
Great. And one last question over here. What are some initiatives that you take about sharing culture? Like for instance, do you actually follow any literature or share any papers that you would share to your team members to read to cultivate the same or consistent culture across the org?
Yeah, I think that's one of the things you get from it.
Yeah, maybe I'll take a quick stab. I mean, I think there is very much a balance between thinking about what do you want to put, sort of top down, like what do you want everybody to receive, versus things like literature and paper reading groups. We found those to be a lot more bottoms up, and people are interested in doing that, taking on those initiatives on their own. So I think there's a balance between being prescriptive and allowing some degree of autonomy.
Jason, do you have anything to add to that?
I think the central team makes it a lot easier to do that. When you're like the only ML person on your team, then it's kind of, you're on an island and it's hard to get a paper reading group organized even. Whereas if it's like the team members that you see every day, it's a lot easier to be like, hey, we're all thinking about this type of problem. I found an interesting paper. Let's read it together. It's way easier.
Cool. So we have one last question. So did you have any challenges introducing a new set of tools such as ML Flow? And if so, how do you overcome the challenge, or how do you encourage adoption?
Yeah, we didn't really have a lot of challenges getting our model platform introduced. And I think it's about the integrations and like the power that the tools and the platform brings to you. So right now, something like productionizing your model might have taken a lot of effort before, whereas now we have fully managed integrated solutions and you just specify which run ID you want and it runs for you. It's just like magic. There's so much work that happened behind the scenes to make that all happen. But the platform provides so much value that people want to use it and like willingly onboard and ask us to be early adopters for these features.
Cool. I see that there's one more question. So I think Jason and Daniel, you don't have hard stop, right? Can I just proceed to ask the last question here? Yeah. So the subgroups within your ML org, are they fluid, or do people actually belong to multiple groups?
If in my experience, as a central team, we have grown over time. I think when we were a smaller central team, it was more the case that there was a lot more fluidity, and it was easier to operate in that way, and manage projects in that way. I do think as the central team becomes larger, it becomes a little bit more difficult to manage. I think there's various strategies to overcome that, but right now.
And perhaps the one last technical question here: do you use the feature store?
So it depends what you mean by that. Yes, we have many feature stores. So if you're saying, do we have a single feature store? No. And I kind of wish we did have a single feature store at some points because it'd be easier to share features. We have many feature stores that all have different types of data in them. And that's somewhat of a problem that we are trying to fix.
So are they custom implementation?
Most of them are based on open source things. Like we're an AWS shop at Yelp, so we have like a bunch of Redshift clusters, and we have some S3 data lakes that are like registered with Glue, AWS Glue, and things like that. So nothing super custom, but it's like built on the cloud technologies, and it's a bit scattered.
Gotcha. So so I'll answer the question about Sleight. So my understanding is that the recording will be posted to YouTube within 2 to 3 weeks, and the slides should be emailed out to the attendants as well. And so thank you all for joining this talk. And before you leave, please rate this talk in the poll tab so that we can know what talks to cater to the audience in the future. And thank you, Jason, and thank you, Daniel, for your time today.
Thank you.
Okay, bye, everyone.